Microsoft, Tyler, is a data science lead at DTN, a company that has a very interesting tagline. It says, it provides operational intelligence for confident decisions. I love it. And of course, he's been a very ardent follower and user of Metaflow for several years, I believe now. So, welcome, Tyler, and over to you.
Thank you, Shri. So as Shri mentioned, I'm a data science platform lead at DTN. It's actually been less than a year, Shri. I know it's felt like years, but pretty new. So let me know if you can't see this, but I think it's working. So the title of my talk is Increasing Velocity with Metaflow. My goal today is to kind of make this like a demonstration of the workflow of our average data scientist at DTN and how they would go from iterations to actually deploying a production flow with Metaflow. Here's a bit of the agenda today. So I'll start with some of the types of things that DTN does, and then we'll get into the different aspects of our architecture and how the data scientists use them. So DTN primarily focuses on three main areas, that is weather, fuel, and agriculture. And so on the data science side of things, there's some examples of projects that we've built and products that customers are actively using. So this one's called Storm Impact Analytics. So essentially, we're ingesting weather forecasts, and it will export and predict on potential impacts to infrastructure, be that power or roads, etc. And what our customers do with this is when they get a prediction, they're better able to allocate resources to send, more people to fix power lines before the storm hits, that kind of thing.
This meeting is being recorded.
On the agriculture side of things, one of our main things we do is crop yield modeling. So we'll ingest satellite imagery data, previous harvest data, in order to generate models for the current year on estimated yields for different crops. This is an example of a graph that comes out of one of those types of models. And then finally, fuel demand modeling. This is on our fuel side of things. DTN is involved with a lot of the point sales systems for the last leg of fuel transport, which is essentially like the tankers to the gas stations. And so with that data, we're able to predict some of the demands over time. And this is an example of the demands year over year during COVID and how it's a little bit lower. So that's some examples of what DTN does on the data science side of things. On to how we do it. So our main interface with Metaflow is through a project called Jupyterhub, and I'll show that in a second. But essentially what Jupyterhub is, it's a pre-configured computational environment. So all we have to do to get someone set up on our environment is just enable their email and our SSO, and when they log in, they have access to content environments, a shared file system, to a decently large amount of compute, and then they're just off to the races. And so I'll show a little bit of a demo of what that looks like. So this is an example of Jupyterhub. And this is actually a production environment. I just created a few example files to show how it works. But I think most of us are familiar with Jupyter notebooks, and so you can execute Python in real time. Each user has the ability to use about 130 gigs of RAM. We had to split that up because it's an over allocated single EC2 instance that this is running on. So if they were unlimited, they would crash the server, which was never fun. But the nice thing about this is that Metaflow is completely set up via environment variables. And so you can see here, we have a shared environment, which is immutable to the user. And so when people iterate on Jupyterhub itself, they'll be using this DS environment. And this is useful because occasionally we have to manually modify Metaflow for certain things that occur in our environment. One of those, for example, is the Kubernetes autoscaler. It was like deciding to try and move pods from one node to another to try and eliminate nodes that were underutilized, and naturally that would break your job and made scientists sad. So it's nice to be able to kind of push out updates to Metaflow so that the users don't have to worry about doing it themselves, and we have consistency across all of our users. The other thing is that Metaflow itself is pre-configured. So here's just a few of the Metaflow environment variables. This isn't all of them because some of them are sensitive with tokens to Argo and that kind of thing. But you can see here that we have like the container image, and this is because pulling from the public Docker container with large jobs was blowing out the limits. And so we pull from Amazon ECR because we run on Amazon. We also have Kubernetes automatically configured. So as soon as the user logs in, it authenticates to our Kubernetes cluster through IAM roles. So it's really nice in that it's like a click button solution to get your data scientists up and running.
Hey, quick questions here,
Yeah, sure.
Tyler. So is Jupyterhub itself also running on Kubernetes, or is that a separate setup and the Kubernetes environment for Metaflow is a separate setup?
It could be. Currently, it's not. So right now, it's just running on a single large EC2 instance. And part of that was just the existing architecture, but the other thing is that it enables us just to use like a single large instance and over allocate it really easily. Whereas on Kubernetes, the default is to have each user have their own pod.
Got it. So one large EC2 instance hosts Jupyterhub. Users log in to, I guess there is a URL for logging in. So you have a UI and then it's authenticated. Users log in. When they log in, all users are sharing the same EC2 instance. So all their Jupyter notebooks are running on the same EC2 instance, which has pre-configured Metaflow. And then when they run their flows, the flows actually run on a Kubernetes cluster that is elsewhere, on AWS, but elsewhere, maybe.
Correct. It's on a EKS cluster on AWS. And that's obviously if they use the Kubernetes decorator, they can also run flows locally.
Of course, yeah. Nice.
And if anyone has any other questions, feel free to ask them as we go as well. All right, so I wanted to show a sample pipeline, like I mentioned, of how a project starts and then actually gets scheduled on Argo. And so we have a cookie cutter repo that data scientists will use to create all of the template files to create a project. And within that, you can schedule multiple flows in the GitLab CI files. And then whenever your flow is pushed to the main branch in GitLab, it will automatically deploy itself to Argo. So to kind of start showing how that works, most of our iteration with data scientists is done in Jupyter notebooks. And then the next step after that, once you have a working concept, is to create a flow file. And so we've all seen Metaflow files. With our setup, we have it set so that flows are put in the source directory. And this is because by default, it will include all of the current Python files and all subdirectories of Python files in the code package. And so here I created an example of adding a really simple function to your source. And so you can test this locally, and then you can also test this on Kubernetes when you want to scale up. And so this is an example of adding the Kubernetes decorator. And here we can see an example of this running. It's worth noting that we also have this set up with the UI, so that makes debugging really easy. You can just click the button with your link and go and look at the UI and see all the standard errors, standard outs for your flows. Once you have your flow set up the way you want and you want to deploy it to prod, you go to the GitLab CI file. So like in the base of the repo, there's a file that is the CI, and this is what GitLab pulls up in order to see what Python files are listed to push through the CI. Let me move this so I can actually access that. So we made it so that this pulls from a template repository. So again, like if we want to change how the template works for all data scientists, we just change the template in GitLab, and then all of the projects inherit from that template. So this is what the template looks like. Hopefully this is big enough. But essentially it runs that Argo-workflows create command. We've added a few additional things, like it will tag it with the git SHA. We also have a Slack webhook on Argo, so that if things fail, it will notify us in a Slack channel. And then this is all triggered to run whenever there's a change to either the Python file for your flow or any of the subdirectories within your source files. And the goal of this is so that the state of your flow is always represented in the main branch, so that when another person comes by to try and like fix your flow if it's broken and the main developer is on vacation, we know the state of the flow and where all the code is.
And I'm guessing that GitLab is configured to have the kubeconfig of the Kubernetes cluster. So when you do Python, whatever flow.py Argo-workflows create, it already is running in an environment that has access to the Kubernetes cluster. It has access to kubeconfig so that it can connect to that cluster and so on, right?
Correct, yeah, and that's where this like CI project user comes into play. So we have it configured to an IAM role that has sufficient privileges to deploy things to Kubernetes.
Mm-hmm. Nice.
And to show an example of this running, so we have a few different like linting steps here with black, rough, YAML lint, etc. We have a testing phase, and then we have this deployment phase where it goes and deploys your job to Argo. And so we've also integrated with Kubecost, and this was kind of a happenstance that Kubecost had a mechanism for this. But within Kubecost, and for context, Kubecost is an open source project that enables you to filter based on different pods or tags, and then it pings the AWS cost API to estimate the cost of your running pods. And so we installed Kubecost, and there's this concept called allocations, and you're able to map allocations to tags and Kubernetes objects. And because the project tag, when you're creating a flow, maps to a particular tag within Kubernetes, we just added that tag, and now Kubecost is able to track all of our flows based on our projects. So as an example of that, this is someone who had a project called First 23, and you can see here that it tracks like the CPU cost, it tracks the RAM, the persistent volumes, etc. It's kind of cool in that it will also show you like increase and decrease of cost over time, as well as your efficiency.
Thanks.
And so that actually was like kind of the sum of my demo. It went a little faster than I anticipated, but if there's any questions, I can dive deeper into any part of this. But thanks for watching.
Questions, anyone? Feel free to either chime in or send it on Zoom chat, or actually I should keep an eye on Ask Metaflow. If you have questions, you can ask there on Slack. I have lots of questions, but if there are people who have more questions, feel free to ask them first.
I have a quick question about Kubecost. Does it also track S3 costs, or is it mostly the Kubernetes cost?
By default, no, because S3
Okay.
isn't directly associated with a Kubernetes object.
Yeah, okay.
With S3, I mean, one of the reasons we did Kubecost is because there's not really a native way in AWS Cost Explorer to like pull out the granularity of pods within Kubernetes. But you should be able to do that in S3.
I have a quick question.
Yeah.
Okay. So maybe I missed that. How are you managing, like, in the deployment process? How are you managing like if you delete a workflow, or for example, or you want to rename it, like what's the kind of cleanup process, or how do you manage the state of what's deployed?
For Argo workflows.
Yeah.
So there's a UI for Argo. If and so that's where we would go. If you go to Argo UI, you can log in and see the state of all of your cron jobs. And that's where you can go to edit things.
So you would just
answer your question.
Well, yeah, just quick follow up. If you want to kind of delete the deployment, you would just go to the UI and delete it there, or?
You can do that. There's also like an Argo workflows delete command in the Metaflow CLI. We don't have that integrated with our GitLab because it's not super common that people fully delete things. But if you wanted to, you could delete it with your flow file.
Okay. It's not related, but it might be of interest. But we've also installed Kubecost, but actually AWS have an integration with it now. That means you can keep more than 15 days worth of data. So yeah, it might be worth.
Is that the one that integrates with the S3 bucket that tracks your costs?
I'm not sure. I don't think so. I think you can add that on, but yeah, it came out last year. Originally, you couldn't do it, but it came out late last year, and now you can. I'm happy to send you a link offline.
Yeah, if you get the link to the docs, that'd be awesome.
Hey Tyler, great presentation. I have a question on Kubecost and the Argo deployments piece. So so are you deploying your Metaflow jobs across multiple clusters and then tracking these costs across multiple clusters, or are these within a cluster? And second half of the question is like, hey, how do you manage to deploy your jobs across multiple clusters and tracking them using Argo as well? So can you talk a bit about that?
Yeah, so all of our jobs are deployed on a single cluster. And I think that answers the second question as well, because we don't deploy to multiple clusters.
Okay.
I think Kubecost by default is kind of like a freemium model. So there's a SaaS offering and that integrates with multiple clusters, but by default, Kubecost, it doesn't have like a integration with multiple clusters.
So Tyler, question about like the data scientist's experience of using kind of sort of this model.
Yeah.
What is their feedback on this? Like when I'm guessing Jupyterhub is something that many people are familiar with, so they are happy to kind of start there. But everything following that, using Metaflow, using Argo workflows on Kubernetes, like what is the data scientist's take on how that setup is and what they like about it, what they may not like as much?
It's kind of like that acceptance curve where you have like the early adopters, late adopters side of things. So some of our data scientists who enjoy learning new tools and trying new techniques were like really eager to try it out and really enjoyed it. I think one of our most positive feedbacks was he realized like an entire module he had created to track models and version them was like now obsolete because of like the artifact management of Metaflow. And he's like, oh, this is so cool. I don't have to like do all of this manage myself anymore. So that was really cool. Some of like the less positive is that there's obviously a learning curve to Metaflow as well as Kubernetes, and lots of like random things that pop up, particularly as you scale up. And so those things I think are a little harder for our data scientists because they don't have really context on like why these errors are happening.
Got it.
And then as far as the like production flow of like how we set that up in GitLab, we design that hand in hand with our data scientists, and in a few different meetings we're like, hey, like, are you okay with this? Like, what do you want to have happen? And that's what eventually led to, you know, our GitLab setup.
Got it. And then data scientists, users rather, any user today can directly run Python flow.py Argo workflows create and it'll create the Argo workflow for that flow on Kubernetes, or the same could happen through GitLab, right? So it's either you create it interactively or through GitLab, it's still the same, or is there like a difference in like the environments, namespaces, whatever?
Yeah, so we did namespace it. So if you look here, we set the namespace to production. So this both puts it in a different Metaflow namespace, which is that project project concept within Metaflow, but it's also a different namespace within Kubernetes because we wanted to have different limits so that we wouldn't have someone testing something out and like blow out the capacity of the cluster, and then our production jobs couldn't schedule anything.
I see.
So when
go ahead.
So by default, within Jupyterhub, if you do like an Argo-workflows create, it will create it within the development namespace. And you could like hard code override it if you wanted to, but people don't really. And then
Sure.
By default, it deploys to prod within GitLab.
Okay. So the production namespace has, I guess, better monitoring, better guardrails around it for better resource utilization or limited resource utilization, so that it can run a production workload. Whereas dev is kind of like, experimentation oriented. Is that right?
I wouldn't really necessarily say it had any different kind of monitoring. It's just within Kubernetes, like namespaces are pretty isolated from each other and by design. And so by having a different namespace, it enables us to isolate like the compute usage from the development side of the house to the production side of the house.
Cool.
But it still uses like the same Metaflow UI and Slack integrations and that kind of thing.
Nice.